Hey everyone, I want to thank you for tuning in to one of EPARTRADE's Race Industry Now Tech webinars. If you're a part of the racing industry or you're just passionate about racing tech, don't forget to like this video and subscribe to our channel so you never miss a new episode. Well, good morning, good afternoon, depending on where you're watching us, and welcome to Race Industry Now here with EPARTRADE. I will be your host, Brad Gilley, joined by Judy Keene and Andrea Brake. Francis Savinian is with us. He is back in his home country of France with a couple little computer woes that he is working out, but we'll definitely talk to him. We have a great guest coming up here today, and we're going to talk cylinder heads with Jason Yao, the CEO of Mast Motorsports. But we do also want to thank some great sponsors that we have here for Race Industry Now, including Performance Plus Global Logistics, Ferrea Racing Components, ARP, Fifth Third Bank, Crowder Cam, C-Tech Manufacturing, and Peak. And looking forward to a fun one here today, Judy.
Thank you, Brad. And when you mention those sponsors, I just think what a wonderful rubber stamp of those iconic racing brands really supporting what we're doing here. We're not just this webinar series. People love our newsletters as well, but we're also a racing platform where you're going to find hundreds and hundreds of suppliers showcasing, just like exhibiting. So if you have yet to sign in to reach out to them and see what their new products and latest technology, please do so. Andrea?
Thanks, Judy. Gosh, well, I've known Jason for many years now, and we've developed a great friendship over the years, and just happy that we can continue to work together now that I'm at EPARTRADE, and looking forward to hearing his webinar today and what he's got to say. So, Brad?
Awesome. Well, thank you, Andrea. Thank you very much, Judy. We'll talk to you all coming up here in just a little bit. And today's topic, engineered for power, a tech dive into Mast Motorsports, cylinder heads across all performance levels by Mast Motorsports, featuring Jason Yao, the CEO of Mast Motorsports. And welcome, Jason. Number one, it's always great to have a fellow Texan on here. I know we're about 3-4 hours away where you are in Nacogdoches, and I'm up here north of Fort Worth in Wise County, but it's a pleasure to have you here today.
Yeah, good morning. Good morning.
Awesome.
It's a great day in Texas, I guess.
Yeah, as long as you have air conditioning.
Yeah, very true.
Tell us a little bit about yourself before we get started. I mean, you've started, in the automotive industry like at 15 years old and have done so many things and well educated along the way.
Yeah, so let's see. I grew up in Metro Detroit, Michigan, so it's kind of one of those things that you are inherited from your birth. The car culture is very much present there, and my grandfather and father worked for General Motors Proving Grounds, so I kind of grew up through those ranks, and kind of one thing led to another, and here I am in 2025. So it's been a fun ride.
Yeah, it is fantastic. All right, horsepower for all. We're going to be talking a lot about that here today. Before we dive in, just give us a quick overview, if you will.
Yeah, sure. So one of the things for Mast Motorsports is there's different levels of horsepower, right? So you have entry level guys that are just getting started, just getting out of school, want to modify a junkyard engine. And then you have customers that want to put 2,000 horsepower and go racing and do it for a living. So we wanted to really capture that essence of this industry and showcase, hey, here's products that we have that can cover all of your parameters. And that's really our mantra. That's something that we've been building for the last 4 or 5 years, and developing products to suit the needs and the interest levels and price points and performance levels for a lot of the industry. So
yeah, I love that you have something for everyone, no matter what level they want to get in. And we'll talk about a lot of great detail. And this is not a, boy, that looks about right, or we'll try this. We're going to be talking about things like computational fluid dynamics and a lot of true detail that gets horsepower as well. Before we start with the presentation, Jason, I do want to let people watching us live here today know that if you have a question for Jason anytime along the way, please feel free to just type it into the chat. We definitely want to be able to talk about what you want to talk about as well. And Jason, I know you have a PowerPoint and some videos along the way and everything, so I'll sort of let you set the stage for those things.
Sure.
And turn it over to you.
All right. Well, let's see. I need to present here. All right.
All right, we'll get you in presenter mode here in just a
There
second.
you go. Thank you.
Things go. Yeah, trust me, you know everything about cylinder heads. I like that. I get stuck on Zoom all the time. So
Yeah.
here we go. But yeah, we have a great presentation. A lot of really neat things to talk about when it comes to technology, and again, when it comes to everything that we're doing in motorsports as well. So go ahead, Jason. Tell us what we're looking at here.
Yeah, sure. So just a little bit about the company. So Mast Motorsports was founded by Horace Mast right around 2006. And Horace is a degreed engineer, mechanical engineer, and just a brilliant mind. And I've had the pleasure of knowing Horace since right around 2007, 2008 when he started the company. And so my relationship built with him through other fields that I was in. And where he started was right out of Texas A&M. He tells a story of coming home after graduation, skipping graduation, and just having the passion for doing Mast Motorsports. So he graduated in 2006 and started the company. Some of the first products was the LS engine, and the control systems was just getting started right around those times. And there weren't really any aftermarket ECMs, wiring harnesses to run those engines. And then one thing led to another, and you start going down those limitations, and you develop products, and you just keep going. So one thing led to another. He started a facility here in Nacogdoches, Texas, which is a pretty rural community. As you mentioned, we're 3 hours southeast of Dallas, and 2.5 hours north of Houston, in this little tiny town of Nacogdoches. And it's the oldest town in Texas, so it's got a lot of history, and it's just a beautiful town. So like I mentioned, I'm originally from Metro Detroit. I've lived in Charlotte, North Carolina. I've been all over in motorsports. So coming to Nacogdoches and kind of this little town's been a lot of fun. So it's a really neat company. It's got a state-of-the-art facility here. We have 5, 6 dyno cells, Spintron, a wonderful manufacturing plants, all things that he built over the years. So it's a really neat company.
Yeah, it is. And everything that you build, everything that you guys produce comes just right out of Nacogdoches, Texas. You don't outsource anything, right?
Absolutely. So some of the things, the character of Horace is, I'm going to find the most optimized way we can do it. So the investments have been, all right, we're going to go to the foundry, and we're going to partner with a foundry, and we're going to learn how to run a foundry. So it goes down to those levels. We're going to make the foundry tooling here. As Horace is an engineer, he's built a team of people all around the world that are on our staff that develop engines and develop CAD, develop the cam, develop all of the facets around it. So 100%, as much as we can vertically integrate, that's really our motivation. And it blew me away when I first saw the facility. So
I'll bet. Well, you lead a great team there at Mast Motorsports as well.
yeah.
And a great group of folks. What engine platforms are we going to be talking about here today, Jason?
Sure. So because where Horace started was the late model engines, so the LS engine, the Gen 3, the Gen 4 LS small block Chevrolet, that migrated to some industrial engine development, as well as the Gen 5 LT. And in 2021, we worked really hard on a Godzilla platform for Ford. So that's really kind of growing. And we've done some Coyote engines here and there, and some cylinder head projects for lots and lots of different applications. So
that's fantastic. And as I mentioned in the opening, this is not, hey, let's try this. We'll put it on a dyno. We'll see if it works. There's a lot of engineering that goes into things ahead of time, right?
Yeah, a lot of that is, we have a lot of really skilled artisan, technicians and people that have been in the industry that have the applied knowledge that we take and really migrate that to as much engineering and merge those facets of technology with, hands-on experience and our machining and all of those facets to try and get the most refined process and project.
Yeah, which is very, very special. Well, let's take us into Mast Motorsports a little bit and some of the things we're going to talk about as we go through the PowerPoint here. How does that
Yeah,
sound?
sure. So a little bit about the company and the projects that we do. Like, as we mentioned, the vertical integration. So we're Texas based. We do 100% of our manufacturing, machining in house. As I mentioned, we do cut our own foundry tooling. We go to the foundry. Obviously, we ran a foundry here in Lufkin, Texas, for a series of years. So we poured our own castings, and our team is very well versed in doing that. So we have a pretty large depth of foundry and foundry works. Even during COVID, a lot of our foundries in Michigan weren't operating or couldn't find people. So we went and ran our own foundry as contract manufacturers in 2020 just to get cylinder heads out the door. So so a lot of our castings originate in Texas and Michigan and Wisconsin and Europe. So most of those castings all come in raw based on our tooling, our designs, and then we machine them 100% in Texas. So we've even gone a little bit step further. We've just introduced our own CNC lathe. So we're making spring retainers and valve guides and valve seats and all the other components that go inside of our cylinder heads today.
I like that. I like that the more control you have over the final product with everything, the more efficient and better you can make it.
Absolutely. And it allows for advancement. It allows us to do things that, as race teams evolve, they don't want those evolutionary things to be transferred to other competitors. And in this market, often duplicated, and we're trying to innovate and develop. So any issues that we see that we want to improve, we want to kind of keep those under our hat. So so that's kind of the mentality of that vertical integration.
Yeah, I like that. Let's have a look at the team that you have there in place there.
Yeah. So this is not our fully inclusive team. We have a lot of people, as I mentioned, that work off site, a lot of remote work, a lot of designers, a lot of engineers. But this is our most of our team in Texas, a lot of young guys all over the country. So they've all moved here to work in this field and build products. So a lot of young guys, but a lot of old seasoned guys supporting it.
That's really cool. Jason, if you would talk about, we talk about horsepower for everyone, and
Sure.
you mentioned entry level. You really have, and if it's okay to reduce it, say to 3, factory mast, you have Black Label, and if I pronounce this right, is it Mozez?
Mozez, yeah.
Okay.
Yeah.
Tell us about each one of those.
Sure. So, well, factory mast is something that we wanted to promote from a factory level. So if you have basically a takeout engine, or you're modifying a junkyard engine or something along those lines, and as well as we can modify a factory casting. So if it's a cylinder head that comes off of the factory, we can improve that cylinder head. We can put larger valves in it. We can port it. We can refine the chambers. We can weld it. We can do a lot of different things to the factory casting. We've taken it one step further, even on the factory mast brand, where it's an as cast port. So where our Black Label is a CNC port, which optimizes airflow, which optimizes performance. We've applied that CNC port now to our as cast line. So now that performance basically moves from a full 5-axis CNC port into a more cost-effective solution with our as-cast factory mast. So an entry-level person can buy. It's not as good as the CNC port, but it's significantly better casting and a better performance on the factory level, entry-level part. So so now the price point comes down because there's a lot less content in the cylinder head. So that allowed us to clean sheet really a few really cool products, which allows a guy to buy a junkyard 5.3 liter LS for $500-600, take the factory heads off, put some of our cylinder heads on it for a little bit of money, and make 100-200 horsepower more, and not have to step into a $5, $6, $7,000 set of black label heads, which are really just, getting the last bit of performance out of it.
And again, as we go up in level, we're talking about what you're doing with your racing or what your needs are. For some people, factory mast may be perfect, even a little bit more than what they need, which is
Yeah.
great. Then you mentioned black label, which is premium, and then the Mozez. Take us through those.
Yeah, sure. So where black label comes in, that really gets into some options. So that takes it's the same casting, but it allows us to really custom tune and custom tailor the cylinder head. So we have a customer that wants to run 100,000 miles, wants to really have something out there that he can run 700, 800, 900 horsepower reliably on a street car. That's where the black label comes in. And you can run turbos and nitrous and really just, it'll take the abuse. You can run race fuels. It opens up the door for a lot more performance and a lot more durability for guys out there going. And it's key to note, where we launched the factory mast, it was really to compete against pressure from import castings coming from Asia and coming from, a lot of different facets and keeping our mentality of, right, we're going to source these in the US, we're going to source them in Europe, we're going to use a high quality casting. So now that goes all the way through to Mozez. And really the Mozez, that's a product line that has the most advancements. That's something that you're going to be able to put 2,000 horsepower to it, and it's going to just keep going and going and going. It's an endurance, a drag race, something that is built for professional racing and people that want to really make the horsepower. So kind of goes along the lines of that good, better, and best mentality.
I like that. Before we dive into the engineering and further into the PowerPoint, tell us about the project that you have going on right now with the standard 5.3 LS based engine.
Sure. So we're kind of deep diving the 5.3. It's a really, really cool platform. It's such an economical engine that everybody can go and buy out of the junkyard and make 1,000, 1,300 horsepower on a factory crank. And the limitations are really coming down now to the cylinder head. And even then, the cylinder head castings are starting to they're harder to come by, they're harder to modify, they've been iterated enough. So that's really where that comes down to. So we're going to be doing a pretty big test that we've built an engine for. We're going to dyno it and take all of the last 3 years of development for the 5.3 and really put it through the paces on the dyno and put some applicable engineering numbers behind it. So it's a really neat, cool. Two of the really neat cylinder heads we're doing for the 5.3 is the cathedral port, and then we're taking which is a 3.780 bore. So that's a small bore for an engine, but it's optimized for that. And then we're taking that 5.3 that has traditionally only ever been available in a cathedral, and we've modified the cylinder head to adopt a LS3 intake. So now it's kind of a unique thing. A lot of people sell adapter kits and have to do all these little things to put an LS3 intake or a supercharger, or pretty commonly available on the market, on the aftermarket, for an LS3. So now you can buy our LS3 5.3 liter hybrid that we're calling it, and put really any LS3 intake on it and achieve some bigger gains. So
That's really cool. Well, let's dive a little further into the PowerPoint and talk about the engineering at Mast Motors.
Sure. So engineering and manufacturing, I think we've already hit a lot about our vertical integration, but it's really key when it comes down to consistency, performance gains, efficiency, and engineering. So those iterations that we're making can happen a lot faster in the computer world, because once you build your model, you can run different matrix of sizes and flow and changes, and all those things can run pretty rapidly. But a lot of that world comes back to building that database and really that applied knowledge that we can take from our technicians and our guys and really our people in the input, and put it into this database and make iterative changes. So and that's really with any engineering process. Now you transfer that knowledge to the manufacturing world. So then you have repeatability. So not only when you hand work a cylinder head port, you have those variations to transfer it to making it, and then making it repeatable, and then making it the same way you made it a year ago or 2 years ago. And then you have the quality of that. So you have to stand by your quality. What changed? Well, when you're working through a quality issue or something, having that database of, all right, here's all the changes that were made, and you can track them all the way through the process. So that's really the steadfast way that we're approaching that engineering and manufacturing at Mast Motorsports. But
That's
sorry.
Oh no, go ahead. I mean, it's really
Yeah.
cool, and this is what's about to be truly impressive. Especially when you start controlling the airflow.
Yeah, and this is really some of the things that Mast hasn't really promoted, because it's been an advantage for the company for a long time. So we're a little bit further down the pipe, and we're showing you some of the early adoptions that we did. But it really comes down to, as I mentioned, digitizing your model and allowing you to make changes. So computational fluid dynamics is something that now we understand. We've benchmarked it, right? We've made them by hand. We've computerized them. We've put them through the manufacturing. We've dyno tested it. So we know that, okay, A matches our model. So now, as we go through the development process, we're launching a new cylinder head, or we're bringing an as-cast port to market. What are those changes really affecting in the design and the intentions of our design? So building that model and allowing us to run all the different facets. Say we want to put a bigger valve in. The valve change may be 50 to 100 thou. It's a relatively small change, but how does that impact velocity? How does that impact swirl? How does that impact the port design? So now we can run through those paces, and it's about efficiency. It's about maximizing that fuel, maximizing that compression, that atomizing the fuel, and I can just go on and on and on about it. But the bottom line is that the picture that we're showing here is really a cylinder head. It's a 4-valve cylinder head that we do for a private label customer, and that's showcasing really the airflow in each chamber and how it interacts as it's coming in to the cylinder and filling the cylinder. And what does that look like? How does that velocity change? Is there swirl or tumble? So you start to actually see what's happening in the engine from a computer model. And remember, like I said, we validated that as much as we can, really. And now all those changes can happen iteratively in the computer.
That's pretty amazing. And it, again, just to see, we don't always get to see these things, like really truly what goes into development and engineering, and especially when you have the numbers to back it up and the graphs and the data.
Yeah. Right. Yeah, and that's that facility comes back to where we can dyno it, we can test it, we can prove it, right? And that's the really cool part, when you're proving out your model and it works. And everything works, right? It's we've had a lot more failures than we've had successes, and that's okay. I'd rather have those failures on our side than our customers. So, but at the end of the day, CFD is really something that's not new. It's been used in a lot of industries. I have an airplane on the screen. It's been used and developed, and we're just really applying it to our application today. So, this is an example of that output. So this is what the data is generating. So you can see in the blue area the mass flow, and you can see the differences between the factory, which is that blue line, and where ours comes in on. All right, that area between the blue and the gray there is where we're really what we're really shooting for, the advancement and the changes that we're making. So now, as you make those iterations, you can really see that effect on it. All right, this change was good, this change was bad, and so forth. So,
yeah, and it's, I mean, just the way that just shoots right up there, and then maintains too. I mean, that's
yeah,
really cool.
yeah, and it's a lot of folks are familiar with Dynographs, and you're looking for 5-10 horsepower changes, and this is really just a computational dynograph for a specific port. And then you can look at swirl and tumble and all of those facets. Now you have 200 graphs to look at while you're making changes, and those iterations and those iterative knowledge base that you can make. And sometimes it becomes too much information. So you have to iterate it down and look at percentage gains and all of that. But the bottom line, it's a tool for us to use on the very front end. It's an investment that we make to really have a state-of-the-art product where we're not duplicating what's out there, we're creating it, and we're doing the work and the hard work and engineering itself.
Yeah. What does the airflow look like if we're looking inside or on top of the cylinder?
Well, you can't tell unless you're in an engine. So the only real way that you can do it is by measuring it or validating your model. But so that's kind of the facet, right? And that's the fun and the the challenge that everybody has. So this is a really good example. So what you have is the side view of the cylinder, and then you have the top view. So this is looking in through, if you were to have an imaginary wall in the cylinder head on the left side of the screen, there's two valves, and the airflow coming in through the port into the cylinder, how it's going around the valve, and you have the blue, the green, and the yellow, and the areas that are slow or higher or lower velocity, and how the direction of those little arrows is where's that flow going in the cylinder head? Where do you want it to land? Well, that's important because that changes where your spark plug goes, how your chamber is formed, where your piston comes up, where your timing is, where now all of those independent parts are affecting your flow or affecting your performance. And on the right hand side is looking down as if the cylinder head's not there. So this is a view into what the airflow is doing, and you can see the arrows showing the swirl and where is it swirling and how is that going. So that allows us to make changes to the piston, the face of the piston, the valve reliefs, the angle of the valve job, all of those things kind of go into it. So it's just a good visual representation of what is that cylinder really doing? What are those changes making?
Mm-hmm. And again, information is great, and it's amazing what technology can do to be able to show us all of that. Well, let's talk about intake and exhaust port placement, layout, and all of those things.
Yeah, sure. So one of those things is as you're doing the layout, as we mentioned, it's not just about the cylinder head. It's looking at, all right, how does that port come into the cylinder? Where is that at? How does the valve train lay out? And you make all of these changes, and it always affects something else. And through my experience in racing and motorsports, it's always something. It's always a compromise, and really the advantages of trying to define those compromises and in looking for that last little bit, right? Is the push rod going to clear the block if we move the valve this way by 5 thou? Oh no, it hits, but then the lifter hits, and okay, the cam. And so you start to look through all those little facets, and most of everything we do happens theoretically in the computer first. And we know by validating our models, by validating all of our designs, that when we make these changes, that's really the next iteration, and just trying to eke out that last little bit of performance, that last bit of quality, and understand that, well, hey, if we make a change, we're not going to detrimentally affect the performance and the quality of the part and the longevity. So.
Mm-hmm. Yeah, for sure. And again, being able to know what's going to happen before it happens, just how much more rapidly that helps you advance with all of that.
Yeah.
And you talk about making everything in house. We saw the Haas CNC behind you in the family picture there with you and all of the staff and everything.
Yeah.
But once you start to design, then you've actually got to build and create tooling paths and all of that.
Yeah. Yeah. So that's really the neat part is now, as I mentioned, you're validating your designs and you're running your tooling paths. And now that you have everything in CAD, you take it to one more step, and you have to design your tools. You have to design your tool paths. How do you actually make that part? Ideas are easy, but the applied knowledge to make that is hard, and it takes a lot of resources. So making those design changes and knowing how finite they are in the computer world, and putting them into more of an applied manufacturing level, this is really where it comes down to computer aided manufacturing, or CAM or tool path development. So as you can see the blue area there, that, and you can see down into the transport, the cylinder head that's transparent. You see that little gold ball there. That's the cutting. That's the cutter that's actually cutting the port. So now you can see, all right, the tool clearance, is it going to rub? Is it going to hit? And you know that, hey, that port is going to be the same on all 4 of those cylinders, and it's going to be repeatable today, tomorrow, and a year from now. So and any changes you make. So that's really kind of that next step.
Mm-hmm. Which is really neat. What does that now look like once we have it inside the machine?
Sure. So just an example of this is a little bit different because that's our tooling on the left, but I wanted to show, all right, here's the automated tool path from a CAM perspective, and here it is cutting it in the field. So so on the left is the computer, and on the right is really the CNC machine cutting it. Nothing spectacular here, just besides, hey, this is the level of detail that it takes to kind of prove out our programs.
Hmm. And I think that is the key right there. Like you talk about repeatability. I always love talking about the compromise that we have in racing. If you gain here, sometimes you're giving up there, and
Absolutely.
how can you fine tune that? And that to me becomes one of the bigger challenges. In what am I giving up if I'm grabbing something over here? And sometimes you can find like that perfect place where you can do both, not give
Yeah.
up, but still make gains, which is great.
Yeah. Yeah, and again, we're in a competitive field, so we're always looking for those advancements, and the faster we do it, the faster we can get it to the customer and the consumer and the racer, and maintain that edge. So so this is a little bit of a dizzying video, but wanted to really showcase a couple of our different products here in one screen. But this is our simultaneous 5-axis porting. You see our factory mast in the upper right. That's a factory cylinder head that came off a GMLT engine, and we're modifying the port. On the left, you see our factory mast head going through, and now you see kind of our castings going through the process and the iterations. All right, this is the different steps. So rather than take everybody through our shop tour, we kind of just put this together to show, hey, this is how our casting comes in. There's the next step. It's a little bit, every step, machine's a little bit more. Now it's ready for valve seats, the chamber's cut. The porting's done a little bit more there. There's some extra clearancing. The next step, you'll see our valve seats installed. So my computer keeps up, and now you start to see the porting. You see here's all the detail that kind of goes into the porting after the valve seats are in, and then you just have that absolute detail that now it's done. So you kind of see that finish.
That's incredible. That really is. What are we looking at here?
Yeah, so this is a lathe that we just put into commission. This month we started making a lot of our own parts. Since we make our own oil pans, this is the oil cooler adapter that goes inside our oil pan. It's a specialized fitting, and we have a real young technician that's 18 years old running this brand new, multi-axis lathe, and so it's really cool to watch him come up. He's going to school for machining, and he made this part. So it's 100% done in-house, and it goes in our oil pans. So.
Oh, that's amazing. And it really is. I mean, again, just all the things we look at, and the more you have control over, like you talk about with the parts you're making and different things like that, and some great resources as well. And look, not taking away from the artistry of someone who had done this by hand for decades and everything, but I think one of the key things here is you talk about the repeatability. The one you make today is going to be the same one you can make next year, but also the engineering that goes into something like this. There nothing about this is that looks right. Everything about this is we can prove that out.
Yeah, and it's important to note that this is all, on the hands of technicians and people that built this originally by hand. This isn't taking away from anything that our experienced people and industry people have done. This is just adding to it. This isn't really anything that changes, you know, it's just an advancement, really.
Hmm. Well, I know we talk about the different levels of product from factory mass to black label to Moses, and you had mentioned different things like being able to, have a hybrid head where you can put an LS3 intake and different things like that. But tell us about some of the products that go into this.
Yeah, sure. So this is just a quick snapshot of, we do, valve covers. We do, you can see a picture there of our titanium retainers and our valve guides and our windage tray. So from this view, you can kind of get a feel for who we are at Mast and some of the things that we do. When you go to the aftermarket, you're going to make an advancement of, we made this change to a cylinder head. What else is available for our customers and those folks that are wanting to modify that engine? If there's nothing available for that, we can't make an advancement of our cylinder head without having to create something. So sometimes that means, for instance, the oil pan that we've manufactured for a very long time, we had to we saw an advancement for a windage tray. So that's a sheet metal part. It's not really our core, but in order to have a higher end oil pan, we had to do a windage tray to match it. So that kind of just complements the oil pan. And a valve cover or something out there that, all right, we want to add more valve lift, but there's not really, at the time, there's not a valve cover available to do the things that we need to do for the cylinder head. So in the upper left, you see a supercharger lid. That's a LSA supercharger lid. That's out of production at General Motors. So we created our own. And so it just that's kind of how these things cascade. In order to do what we want to do, sometimes we have to make it. And a lot of times it starts with a billet or a block of aluminum, and that's one or two pieces, and then the market's pulling you, and all right, we need to make 100 or 200 or 500, and so that's really where the casting comes in. But it's just really a snapshot of what we do.
I want to get back to something when we talk about compromise, and you're talking about that hybrid cylinder head. Now all of a sudden you're making direct fit parts, and you're making both sides of the direct fit. And you'd mentioned earlier, like, hey, look, you can get an adapter, or you can do something like that. But anytime you do something like that, you're giving up a lot, aren't you?
Right. Yeah, it opens up the door for failures. It opens up the door for part fitment and complication, and anytime we can smooth that path and make it easier, your customers are going to be happy. You're going to have a higher quality part. It's one less part you have to buy. A lot of the times when you're building a hot rod, you're exhausted of just going and finding a bolt, or you're at that last end, and there's nothing worse, and you want your project done, and you're having to go back to the hardware store 10 times to finish it. So it is anytime we can upstream that in for our customer, we're going to do it.
Yeah, I like that. Well, give us a little more detail again with the factory mass, the black label, and the Mozez.
Sure. This kind of gets down to some nitty gritty details of the three different product lines. And a lot of this is available on our website and downloadable, but it really highlights what we were talking about for the different brands in our company. Where the factory mast is as cast ports and as well as CNC ported factory castings. The factory mast lends itself to, hey, this is a factory part. We're going to complement the factory performance. We're going to advance the factory performance, but we're going to keep it in the mindset of, you have a junkyard engine, you want to put this on and run 1,000 horsepower, go for it, and then, as those projects go, as all motorsports does, you want to upgrade a little bit, and you need to put more horsepower. You're looking for 15 to 2,000 horsepower. And all right, I've had some failures here, but that's because I'm running, 30 PSI a boost. And that's where the black label comes in. You've trialed out, you've validated, and you want a little bit different aspects and different features. And the black label is really where it comes down to. And the availability for that product on the black label is LS and LT. So we do a Gen 3, Gen 4 LS, and we do a Gen 5 LT. And then the Mozez is really, there's really only two cylinder heads for the Mozez product line. It's called our canted valve. So that's a valve that is angled to optimize airflow. That's more specifically tailored to drag racing and higher lift, higher RPM higher horsepower applications. And that's something that we're launching a brand new cylinder head in next year that's going to revolutionize the LS market, which is more, it's going to be our inline Mozez, and that's going to be more towards like our NASCAR and our endurance, very high RPM applications. So more along the lines of valve train stability for high RPM endurance motorsports like Baja, you know, street race, or not street, circle track racing and those legs. So
Very cool. You definitely have to come back and tell us about that when you get that one
yeah,
out there.
that's we've been working on that one for 2-3 years, and it's gonna be really a trick piece. I'm really excited about it. That's a pet project of mine. So
Nice. That's awesome. All right, let's have some fun with the Castamania and Montreal.
yeah, so you know, we do have some fun with marketing. We you know, we like to keep it light, and so we rolled out the campaign, and of course, you know, you can't have Hulk Hogan and Macho Man Randy Savage, you know, kind of highlighting your products, but in reality, it's just having some fun and you know, keeping it light and enjoying what we do. So but showcasing, hey, this is our budget, this is our built for your budget, this is horsepower for all, this is what we're doing. And I point out that here's the products, and again, a lot of this is built on our website, a lot of this is available at our dealers, and it's a growing product line for us. But one thing I do want to highlight here too is if in the center of the screen you can see the cylinder head with the numbers on it and the QR code. One of the things that we put in place about 3 years ago is every single cylinder head that we produce has a serial number that's locked in when it ships to that customer. So if that customer has an issue in the field, we can 100% sort that and find it to when it was cast, when the material was poured, what the alloy was, look at the foundry records and go all the way back up through that chain. There's pictures of it being assembled. There's work orders that are tied to that number. So now we have 100% lot traceability. So, you know, there are issues and sometimes every now and then, but, you know, we are generally immune to a lot of those issues because we designed that out in the beginning. However, being able to lock down and look at those iterations and have that, it's a really important facet. Not a lot of folks do that in the industry. So
that attention to detail, as we all know in motorsport.
absolutely. And just being able to do that from a systems approach and a business systems approach is, you can't even begin to fathom how hard that is to manage and keep track of that information, but we do it, and it's something that we're dedicated to.
I like that. You offer some other things, from port injection conversions to billet aluminum manufacturing and so on. Tell us a little bit more about that.
Yeah, again, you know, as one thing led to another, the LT engine comes from General Motors as a direct injected engine, and managing that fuel system and getting the horsepower with direct injection has been a little bit of a challenge. So one of the things that we did early on with our LT platform, we proved out and we made engines, LT engines that can be run on port fuel injection. So basically it's taking an LT engine and running it as if you were running the fuel injection system on an LS engine. So now with our LT2 modified intakes, you can run a standard LS style port fuel injector on an LT engine and with a standalone system. So now you can adopt a Holley or a Haltech ECM with our port fuel injection, and you don't have to run the direct injection system. So now that can be put into any number of products without running a, you know, a factory ECM and modifications. So one of those things that we did early on.
Impressive. Very impressive.
So, and I mentioned billet. So, you know, a lot of the times the volumes don't necessitate building casting tooling and making that investment. You know, when you make an investment in casting, it can go to $150,000 if you want to do the volume, and depending on what the product is. So it can go anywhere from $100,000 to $250,000 to make casting tooling. So sometimes that necessitates building parts out of billets, taking a chunk of billet material and machining it down and doing it. So what you see on our left is our Mozez valve cover. That's a 100% billet chunk of aluminum that we started with, and it goes on on the engine. Since we don't do a lot of volume, billet is the right choice. In the middle, you see our billet Godzilla intake. That's a very high-end intake. That's a $6,000-$7,000 intake, but it's rated for boost. It's rated for 2,500 horsepower. You know, it's rated for whatever you want to put after it. And on the right is our Mozez intake. So that's a little bit more of a hybrid. The lower is a cast aluminum piece, and the top is billet, and then the throttle body is billet. And so, you know, as that integrates or evolves, you know, that's kind of those features. So we have that capability here, and they turn out to be beautiful pieces of design and manufacturing.
Yeah, it's great when you can make something look good that also works very well.
Yeah, yeah.
I like
But,
that.
and then I mentioned covers and billet and cast. So just a little bit of a picture of, all right, here's upper left is our LSA lid. So that's the supercharger lid that goes on the LSA GM platform. That was available on a Camaro and a Cadillac. And we took that part and we designed it so it could be used with a Cadillac and or Camaro. And a lot of aftermarket superchargers are adopting that LSA platform. So, you know, we decided to offer that as an option, and that's something that has been very popular. But again, that went out of production, so we decided to do it.
Yeah, I like that. I know we're getting a little short on time, but yeah,
Yeah.
let's talk about the private label manufacturer.
Sure. So a lot of the things that we don't promote, we do a significant amount of private label manufacturing. So a lot of cylinder heads that are out there have our design, our manufacturing done for a lot of performance companies. So, you know, we'll manufacture your cylinder head. We can put your logo on it. We can design one and do it for you. So some of the things that we do, we don't promote, but they're out there, significant volumes and significant numbers. So something that we do every day. We make parts for other folks and take that applied knowledge and give it to them and their customers.
That is a great thing. I think we are running out of time a little bit. Hey, look, we would love to have you here again, and
Yeah.
and I can assure you, next time I make my way through Nacogdoches, I'm definitely going to look.
Yeah, sure.
Would love to see it, but this is it's incredible, the products that you guys are turning out, and
Yeah.
how well made and well engineered everything is.
Awesome.
Awesome, Judy.
Well, thank you, Brad. That was interesting and educational. So next week, we're taking a week off, but we will be doing another webinar July 16th with Canton Racing Products. But if you're interested in reaching out to Jason, please log on to the platform. We're going to push his products up to the front of the home screen. And thank you for joining us.
Thank
Yeah,
you, Jason.
thank you very much for having me.
Bye, Jason.
Thank
Bye.
you.
Hey, we want to thank you for watching. Now, be sure to like, subscribe, and click on the bell so you're always up to date with the latest racing technology, industry insights, and exclusive content from EPARTRADE.
EPARTRADE is a digital platform that we've created basically to make life easier in the business community of auto racing.
EPARTRADE, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier.
When you see a product that you're interested in, all you need to do is click on request more information, and then from there it is forwarded directly to the buyer or to the supplier.
EPARTRADE really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Land speed record holder George Poteet's Speed Demon rocketed 481 miles per hour at the Bonneville Salt Flats. You don't go that fast without ARP fasteners.
There is no way that we could go the speed that we've gone, the number of times we've gone, with a lesser quality bolt than ARP supplies to us. And we absolutely wouldn't be where we were today if it weren't for ARP.
When failure is not an option, it's ARP-bolts.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def and Blue Def Platinum. Put trust in your truck.
With roots in the Midwest that date back well before the Model T, Fifth Third Bank has a long history of serving the needs of automotive companies. While much has changed over the years, our passion for helping businesses put cars on the road and on the track has not. Today, we are more committed than ever as a member of SEMA, a founding member of PRI, and a sponsor of multiple race teams across several racing series. Where can we take your business? Fifth Third Bank.
Where will you find Farea racing components, circle track, drag racing, and any top race shop? In every form of motorsports competition, our valves and valve train components deliver race-proven design and technology. And we've brought that same performance to our street applications as well. We're backed by 5 decades of experience, an extensive range of off-the-shelf components, and our custom valve department has the fastest turnaround times in the industry. Farea Racing Components. Stand with us or race against us.
When it comes to pushing the limits of performance, the pros know there's no room for compromise. At Crowder Cams, we don't just engineer camshafts and valve train components, we redefine what power means. Since 1955, Crowder Cams has been the name trusted by racers, engine builders, and gearheads around the globe. Whether you're building a street machine, a dragster, or a track car, Crowder Cams provides the muscle you need to dominate. And with Crowder, victory is within your reach.
At SeaTech, we're on a mission to lead the storage industry through innovative custom-built solutions that meet every challenge head-on. Designed for versatility, whether in a commercial setting or at home, we create high-quality, durable products that stand the test of time. SeaTech, engineering and innovation.